children, today our topic is centripetal and centrifugal force. Alright, now first we will learn what is centripetal force. Now in case of centripetal force, first I would like to give you some examples which I am sure you all have played in your regular life. Like for example, with this ID card and with this belt, what do I do sometimes? I keep on whirling it round and round and round. What do I see? It is moving in a circular motion. Okay, and is it moving with uniform speed? That is equal distance in equal interval of time? Yes, it is moving with uniform speed and in circular motion. Alright, now suppose if I let it go, I move it at a very high speed and I just let it go. What will happen? It will just fly away, right? Now, I will draw the same thing. I have drawn the same thing on the board. Here suppose I am standing and here I am twirling this iCard round and round. Okay, so it is moving in a circular fashion. You can also do this with a string and a stone. Alright, now what is happening? Let us check. As I said, it is moving in uniform speed. But my next question is it moving in a uniform velocity? Think again. If in case I snap the string, what will happen? The stone will fly this direction. Or if it is coming over here, okay, like it is moving in a circular motion, if it comes over here and then I snap the string, it moves in this direction, almost at 90 degree or at a tangential direction. Alright, same over here. If the stone comes to this position and I let it go, it will move in this direction. In all the cases, we find that the direction is continuously changing. Whenever there is a direction that is coming into play, we will consider it to be a vector quantity. Here, the magnitude of the speed is not changing. It is 5 meters per second. But the direction is continuously changing. As a result of which, we know that velocity depends upon magnitude and direction. So here there is a change of velocity. We cannot say it is moving in uniform velocity, even though the body is moving in uniform speed. Okay, so there is a change of velocity because of the change of direction. And we know that the rate of change of velocity is acceleration. So is there an acceleration also in the body? Yes, there is an acceleration that has also come into play. Now, one more thing is momentum. What is momentum? We had read earlier that momentum is equal to mass into velocity. And here, since the velocity is changing continuously, okay, then the momentum also is changing. We can say it is a vector quantity. Momentum is also changing. Now, remember the second law of motion of Newton? What did Newton say? That the rate of change of momentum is directly proportional to an applied force or to an external force and acts in the direction in which the force acts. Therefore, the rate of change of momentum is directly proportional to the applied force. That means there is a force also that comes into play. And this force here is acting inwards. If you are doing a merry-go-round with your friend, you can feel this force, that you are pulling each other towards each other, right? So this inward force is called the centripetal force. Okay? Centripetal force comes from two Latin words, center and petal. Now here, center means towards the center and petal means seeking to. That means it is seeking towards the center. It is always moving inwards. This is a centripetal force. Okay? One practical example is the spinning of the washing machine. If you have seen, while the washing machine is spinning, and all of a sudden when it stops, all the clothes tends to fall towards the center. Or for example, the moon that is revolving round the earth. Here also you will see that due to the gravitational force of the earth, the moon is going around it. The gravitational force is pulling it towards itself, and in this case, the centripetal force is the gravitational force. Thank you.